A capacitor has square plates each of side A, making an angle theta between them as shown. So that for a small theta, the capacitance is C equals to epsilon naught A square by D into under bracket 1 minus theta A by D. Solution. Consider an elemental capacitor of width dx at a distance x as shown in figure. Here tan theta equals to y by x, hence y equals to x tan theta. Separation between plates of elemental capacitor equals to y plus d equals to d plus x tan theta. Area of plate of elemental capacitor dA equals to A dx. Hence elemental capacity dC equals to epsilon naught dA by y plus d equals to epsilon naught A dx divided by d plus x tan theta. Hence total capacitance of the system C equals to integration of dC to the limit 0 to A equals to integration 0 to A epsilon naught A dx by d plus x tan theta equals to epsilon naught A by tan theta integration 0 to A tan theta dx by d plus x tan theta equals to epsilon naught A by tan theta log under bracket d plus x tan theta in the limit 0 to A. Hence C equals to epsilon naught A by tan theta under bracket log d plus A tan theta minus of log d equals to epsilon naught A by tan theta log d plus A tan theta by d. If theta is a small, tan theta equivalent to theta. Hence C equals to epsilon naught A by theta into log 1 plus A theta by d. Since log 1 plus x equals to x minus x square by 2 plus dash 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 for x very less than 1. Hence C equals to epsilon naught A by theta under bracket A theta by d minus 1 by 2 A square theta A square by d square, neglecting other smaller terms. Hence C equals to epsilon naught A by theta into A theta by d into under bracket 1 minus A theta by 2d equals to epsilon naught A square by d into 1 minus A theta by 2d. Answer. A spherical capacitor. 1. Outer sphere is earthed and inner sphere is given charge. The outer sphere is earthed. Its potential will be 0, that is VB equals to 0. B represents outer sphere and A represents inner sphere. And so if Q is the induced charge on cell B, then VB equals to 0. This implies Q by 4 pi epsilon naught B plus Q dash by 4 pi epsilon naught B equals to 0. This implies Q dash equals to minus Q. So the electric field at P between the cells E equals to EA plus EB equals to 1 by 4 pi epsilon naught Q by R square plus 0. EB equals to E in equals to 0. Hence integration VA to VB dV equals to minus integration E dr to the limit A to B equals to minus of integration A to B 1 by 4 pi epsilon naught Q by R square dr equals to minus Q by 4 pi epsilon naught integration A to B dr by R square. This implies VB minus VA equals to minus Q by 4 pi epsilon naught to the limit A to B under bracket minus 1 by R. This implies VA minus VB equals to Q by 4 pi epsilon naught अंडर ब्रैकेट 1 बाई ए माइनस 1 बाई बी, और डेल्टा V इक्वल्स टू क्यू बाई 4 पाई एप्सिलॉन नॉट अंडर ब्रैकेट 1 बाई ए माइनस 1 बाई बी। हैंस कैपेसिटेंस C इक्वल्स टू क्यू बाई डेल्टा V इक्वल्स टू क्यू डिवाइडेड बाई क्यू बाई 4 पाई एप्सिलॉन नॉट इंटू अंडर ब्रैकेट 1 बाई ए माइनस 1 बाई बी। और C इक्वल्स टू 4 पाई एप्सिलॉन नॉट इंटू ए बी डिवाइडेड बाई बी माइनस बी। क्वेश्चन 1, फ्रॉम अबव इट इज क्लियर दैट 1 एज b टेंड्स टू इन्फिनिटी, इक्वेशन 1 gives C equals to 4 pi epsilon naught A, that is a spherical conductor is a spherical capacitor with its other plate of infinite radius. C equals to 1 by 4 pi 1 by 4 pi epsilon naught into 1 by A minus 1 by B. When B tends to infinity, C equals to 4 pi